Using a single-phase wattmeter to measure real power in an unbalanced three-phase system is not accurate because the power distribution is not evenly distributed across the phases. Using a single-phase wattmeter on each leg and adding the readings together will result in incorrect real power measurements due to the phase differences between the legs. The most accurate method for measuring real power in an unbalanced three-phase system is the 2-wattmeter method. This method involves using 2 wattmeters to measure real power on 2 selected phases. The sum of these readings represents the total real power. The steps for the 2-wattmeter method are: firstly, connect 2 wattmeters to the 2 selected phases, typically lines A and B, with the proper voltage and current connections. Secondly, record the real power readings P1 and P2 displayed on the wattmeters. Thirdly, sum the real power readings from the 2 wattmeters to obtain the total real power, P. The formula is P equals P1 plus P2. The 2-wattmeter method is accurate even under unbalanced load conditions. If you need an economical solution for measuring real power in an unbalanced three-phase system, consider using a power meter specifically designed for such applications. These meters typically use advanced algorithms to calculate real power accurately under unbalanced load conditions. The flute meter mentioned can be used for measuring real power in a balanced three-phase system, as it uses the 3-wattmeter method internally and provides an accurate reading for total real power under balanced load conditions. In an unbalanced system, power is not evenly distributed across the phases. When using a single-phase wattmeter on each leg and adding the readings, this will result in incorrect real power measurements because it doesn't account for phase differences. For accurate measurements in unbalanced three-phase systems, the 2-wattmeter method is recommended. The 2-wattmeter method is a technique used to measure the total real power in a three-phase system, regardless of whether the load is balanced or unbalanced. It uses 2 wattmeters connected in a specific configuration to measure the power in 2 of the 3 phases. The readings from these wattmeters are then combined to determine the total power. Here's how the 2-wattmeter method works. Firstly, connect the current coil of wattmeter 1 in series with phase A and the voltage coil between phase A and phase B. Secondly, connect the current coil of wattmeter 2 in series with phase C and the voltage coil between phase C and phase B. The total real power, P total, is the sum of the readings of the 2 wattmeters, P1 plus P2. The 2-wattmeter method is based on the principle that the instantaneous power in a three-phase system can be completely determined by measuring the voltage and current in 2 of the 3 phases. The third phase's power can be inferred from the other 2. This method provides accurate results for both balanced and unbalanced loads, making it a versatile tool for power measurement in various three-phase systems. If the load is balanced, the power factor can be calculated using the readings from the 2 wattmeters. The power factor is equal to the cosine of the angle between the voltage and current. In a balanced system, the power factor is the same for all 3 phases. If one of the wattmeters reads negative, it indicates that the power factor is less than 0.5. In this case, the negative reading should be subtracted from the positive reading to obtain the total real power. This situation typically occurs when the load is highly reactive. When using the 2-wattmeter method, ensure that the wattmeters are properly calibrated and connected. Incorrect connections can lead to inaccurate readings. Also, be aware of the voltage and current ratings of the wattmeters to avoid damage. Power meters designed for unbalanced loads use sophisticated algorithms to accurately calculate real power by considering the individual phase voltages and currents, as well as the phase angles between them. These algorithms typically involve complex mathematical calculations and digital signal processing techniques to ensure accurate measurements under varying load conditions. These meters often provide additional measurements such as voltage, current, power factor, and frequency, offering a comprehensive view of the power system's performance. Some advanced power meters can also perform harmonic analysis, identifying and quantifying harmonic components in the voltage and current waveforms, which is useful for diagnosing power quality issues. Another alternative is to use a 3-phase power analyzer. These devices directly measure voltage and current on all 3 phases and calculate real power. Power analyzers are generally more expensive than the 2-wattmeter method but offer greater accuracy and convenience. When selecting a power measurement method, consider the accuracy requirements, budget, and the complexity of the measurement setup. The 2 wattmeter method is a cost-effective solution for many applications, while power analyzers are suitable for more demanding situations requiring high precision. Remember that safety is paramount when working with electrical systems. Always follow proper safety procedures and use appropriate personal protective equipment, PPE, to prevent electrical shock and other hazards. Before making any connections or measurements, ensure that the power is turned off and the circuit is de-energized. Use a properly rated voltage tester to verify that the circuit is dead. When working with live circuits, use insulated tools and wear appropriate PPE such as insulated gloves and safety glasses. Never work alone and always have a qualified electrician present to provide assistance and ensure safety. The 2 wattmeter method is a practical and accurate way to measure real power in unbalanced 3-phase systems. By following the correct procedures and taking necessary safety precautions, you can obtain reliable power measurements for various applications. For those situations, let us recap the 2 wattmeter method again to reiterate its importance. Remember that to accurately measure real power in an unbalanced 3-phase system, you should follow these steps. Firstly, properly connect 2 wattmeters. Connect the current coil of wattmeter 1 in series with phase A. Connect the voltage coil of wattmeter 1 between phase A and phase B. Then connect the current coil of wattmeter 2 in series with phase C. Connect the voltage coil of wattmeter 2 between phase C and phase B. Secondly, take readings from both wattmeters. Record the real power reading PON from wattmeter 1. Record the real power reading P2 from wattmeter 2. Thirdly, calculate the total real power. Sum the readings from both wattmeters using the formula P total equals PON plus P2. By following these steps, you can accurately measure the total real power in an unbalanced 3-phase system using the 2 wattmeter method. Remember to ensure that the wattmeters are properly calibrated and connected, and always follow proper safety procedures when working with electrical systems.